Hello, room 10. Today's math lesson is 8.4, use models to subtract fractions. So we're going to continue our work with fractions. Yesterday, we were working on adding fractions with like denominators. Today, we're going to start subtracting fractions, again with like denominators. Let me move this down so we can look at our learning target for today. Learning target, I can use area models and number lines to subtract fractions. So similar to what we did when we first started adding fractions, we are going to work with area models and number lines. All right, so let's take a look here. I already drew a number line, and it goes from 0 to 7. And here's an arrow. We start at 7, and then it goes backwards to 5. What do you think the subtraction problem is that's modeled here on the number line? If you said 7 minus 2 equals 5, you would be correct. But actually, these are fractions, not whole numbers. But it is similar when you subtract fractions as you do with whole numbers. So instead of the 7, this is actually 7 sevenths, and which is the same as 1. 7 sevenths. And then you go back 1 seventh, 2 sevenths, and that equals 5 sevenths. So let's go ahead and write that equation down. So it's 7 sevenths, that's where we started with. And between every time you move from one fraction to the next in this number line, it is 1 seventh because it's divided into 7 parts. So 7 sevenths, count with me, minus 1 seventh, minus 2 sevenths. So 7 sevenths minus 2 sevenths equals, who remembers, it's just like what you did with addition. You keep the denominator the same. Don't forget that. That's really important. And then you subtract the numerators. 7 minus 2 equals 5. All right. Now, we've worked with the number lines to model the subtraction with fractions. We're going to move on to using an area model. So actually, this area model is the same as this number line. It's a rectangle that's divided up into 7 parts. 1, 2, 3, 4, 5, 6, 7. So let's go ahead and do the same thing. You do the same subtraction problem. Let's say we have 7 sevenths as this area model shows, and then we're going to subtract 2 sevenths. So let's go. All you're going to do is you're going to cross out 1 seventh, 2 sevenths. So what is left? 5 sevenths. So first we had 7 sevenths. We crossed out 2 sevenths, and that equals 5 sevenths. All right. So actually, this might be a good time to label these. So every square is a seventh. 1 seventh, 1 seventh, 1 seventh, and 1 seventh. Okay. All right. Let's go ahead and do a few problems together. Let me go ahead. For the first example, let me see if I can zoom a little bit. There you go. We're going to draw a model to show 9/12. Well, I'm going to use the area model because I think that's easier. But if you want to do a number line, go right ahead. And we need to divide this up into how many equal parts? Well, you need to look at the denominator, 12, because that tells you how many parts we have all together. All right, let's see if I can do this evenly. That's 2. Let's see, we need 6 on this side. 1, 2, 3, 4, 5. That's not too bad. 1, 2, 3, 4, 5. Okay, so there's 12 12 because I need 12 parts all together, and we need to show 9 12s. So let me see if I can do that in color. That might be a little bit easier to see. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 12s. Okay, let's look at the next part. Use your model to find 9 12ths minus 5 12ths. Explain your method. Well, let's go ahead and copy our model of 9 12ths. Alrighty, so here's 6. Oh, I'm sorry, I can't see. I'll move that over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's see, 9 of them. 1 12th, 2 12ths, 3 12ths, 4 12ths, 5, 6, 7, 8, 9. All right, so that's what we started with, 9 12ths. We need to subtract 5 12ths. Well, the reason I like using the area model is because you can just cross out, right? So I'm going to cross out 5 12ths. 1 12th, 2 12ths, 3 12ths, 4 12ths, and 5 12ths. And what are we left with? We're left with 4 12ths. So this would be 9 12ths minus 5 12ths equals 4 12ths. All right. The next part says write two fractions that have a difference of 7 12ths and explain your reasoning. Well, the difference, when you see the word difference, it means it is a subtraction problem. So we need to find a number sentence or an equation where the answer is 7 12ths. So let me think. How about if we try 10 12ths minus 10 minus what will give me 7? 3. 10 12ths minus 3 12ths equals 7 12ths. Okay, so what did I do? Well, I found two numerators that had a difference of 7. Difference of 7. And their denominators was 12. Denominators was 12. All right. I hope you're with me so far. Let's go ahead and turn the page. Now, we used to do these pages in class, but right now all you're doing is the homework and practice page on Big Ideas Math Online. All right, so this top part is an example. If it is an example of what we just did, just with different numbers. I'm going to move down here to the show and grow part. So here's your problem. 9 tenths minus 4 tenths equals blank. Well, it's the same as if you add. You take a look at the numerators. In this case, it's 9 minus 4, which is 5. And what do you do with the denominators? You just keep it the same. So the answer is 5 tenths. If you need to use the area model, go right ahead. It would just be if you shade in 9 parts, and then you cross out 4 of them. 1, 2, let's get a better pen. 1, 2, 3, 4. And we see what we're left with. And if you count them up, that's 5 parts out of 10, or 5 tenths. Let's do one more. 6 fourths minus 2 fourths. Oh, this time they have a number line for you. If you're not comfortable with the number line, go ahead and draw an area model like this one. But maybe you don't even need it. 6 fourths minus 2 fourths. You need to take a look at the numerator and subtract. 6 minus 2 equals 4. And then you keep the denominator, 4 fourths, which equals 1. Okay? If you were to use the number line, you would start at 6 fourths, which is right here. And you need to go backwards 2 fourths. 1, 2. And that is your answer. I hope this was clear to you, boys and girls. As always, if you have a question, feel free to send me a message on Class Dojo or a private comment on Classroom. Okay, it's time for you guys to start your math work. I'll see you guys later.